Hello everyone, this is Wei, and today we're going to talk about OpenLive3D, and more specifically, we're going to go through our devlog for November. And in this devlog, we're going to firstly thanks our hero members, right? So these are two of our heroes in OpenLive3D. The first one is Roach. He volunteered to help on the Electron development, and he also helped a lot in the community. So here we listed his YouTube channel. He played with the Opera model that he developed a lot. So yeah, go and visit his channel. I will have these links in the description. And the second hero member that we would like to thank is Chloe Moon. Right, so she is the first known member that we actually know that stream on Twitch. Right, so we have a lot of members, quite some members, and we have members recording videos. But I believe she is the first one who ever streaming using this OpenLive3D. So here is her Twitch channel, and Chloe also helped a lot in the debugging process of OpenLive3D. So yeah, come and visit her. We will also have the link in the description. Other than thanking our hero members, here we are going to talk about the major improvement, major development items that we have done this month. The first one is the health check loop, and the second one is the ultra fast mode. These two implementation are to improve the first one to improve the resilience of this application so that it will not stop. It can continue running. And the second one is the mode that will require less CPU and GPU computation when we are streaming and playing games that use GPU or CPU. Right. So yeah, these are the two major development items. We also improve our documentation and also some of the like little implementation improvement in our like hand and head tracking, things like that. But yeah, these are two major development items. We in this video we're going to do a little bit deeper dive into what we had done in these two items. The first one is a health check loop. Right, so in this implementation, what we have done before we start improving anything is that this OpenLive3D use a ping pong way of processing. We'll capture the image from our video and then we'll throw that into our machine learning model in a different thread. So this machine learning model, after processing it, it will return some information. It will return where your hand are, where your head is, and also like whether your the position of your mouse, the position of your eyes. However, these information are basically positioning information that we can see from this image, and we'll need to transform these information into our motion vector, motion information that we can use in our 3D model, right? So after this machine learning model is computing and processing and return the result, we will need to use this motion information extraction that we developed in our main thread to process it. And while we are processing it, we kickstart another process. We extract the image, we capture the image, and we throw it to the machine learning thread again, right? So this is like a ping pong, right? So ping the machine learning processing, and then pong, we will extract information, turn that into data that we can use in our 3D model, and we pong it back so that we kickstart another machine learning process. This implementation is troublesome because if anything stops in the middle, the process will stop, right? So it's like dropping the ball in the ping pong game. You have no way to continue to run anything, right? So we detected this when we are first trying to debug with Chloe Moon to help her run some process when she was streaming. So a quick fix that we implemented is that whenever we detect something, we will kickstart another process. We detect an error, we'll trigger another one. And we quickly found out that sometimes when we see an error, it doesn't mean that the process is not processing, right? So things may still keep going, but we get an error, so we kickstart another process. Because these two, the machine learning one and also the main thread, are running in different thread. So it's quite troublesome, it's quite difficult for us to debug, to throw the arrow back and forth like within these two threads. It's basically impossible for us to know what another thread is getting an error. So at the end, we decided to implement this health check loop. So with this health check loop, we're basically having another loop keep checking and to detect if this process is correctly running or not. And you will keep the latest key. So you will generate a lock and a key and put a key through our machine learning model that is running in another thread. So when this machine learning model is returning a result, it will use a key to try to unlock this motion information extraction. So when we detect something is going wrong, we will refresh the lock and the key. So when the machine learning is returning result and is not using the latest key, it will not trigger another process. And we can make sure that our ping pong game is always going, because whenever there is a ball is dropping, we will just give the player another ball, right? So that's quite obvious. And we will keep track of the ball, the ID, the number of the ball, so that we make sure that there is only one ball that is playing in this ping pong game. Right, so this is the first implementation of health check loop. The second implementation that we've done this month is the ultra fast mode. Ultra fast mode is something that we figure that we will have to do when we are talking to Chloe Moon while she's trying to streaming while playing some video games, right? We figure that the OpenLive3D is not smooth enough, use too much resources, because we're running this holistic model. So what holistic model is that we're basically running three different models. So in this illustration, we're seeing three different colors: blue, green, and orange. Ignore the yellow arrows in the middle. So blue is the first model that we run. This model is the body pose detection model. Right, so in this body pose detection model, we detect where your head is, where your hands are, and we even detect like your body torso or even your leg, right? So in this body pose detection model, we detect everything. And then from this information, we know where your hand are, where your head is. We run the green model. The green model is the facial landmark detection, so that we can know that whether your eyes are open, whether your mouth is open, and what's the rotation angle of your head, right? And also we will run the orange model, which is the hand gesture detection, so that we know that your finger is stretching or they're curving. So this require quite a lot of computation. So we figured that maybe we can simplify this and develop the ultra fast mode that only detect your face. Right? So we still need two models. The first one is the face detection model that will detect where your face is in the image. And the second one is a facial landmark detection to still like process whether your eyes are open, where your mouth is open, and the rotation angle of your head. Right? So this theoretically reduce the computation resources that we need by 70%. So it's quite a lot. Right? So now we're seeing that our member are able to streams on Twitch while playing games that is quite CPU and GPU demanding. So yeah, these are 2 items that we developed this month. And thanks for all the members that supported us. And if you've got any questions, leave a comment down below. And also, like if you like this video, and also we will be very appreciated if you will subscribe to the channel. And that's it. Thank you.